Hi, good morning. Welcome to our third video for AP Psych. We're going to be looking at research methods, and this is a very important unit because we're going to use it in every unit to come. So we have to learn about how to research and the correct methods and what that looks like. So here's your learning target. It's really just one big learning target that incorporates all the stuff that we're going to talk about, but we're just going to look at the different types of research methods, their purpose, pros and cons, and then the different types. Okay, so let's start with correlations. So if you look at the word correlation, it's co for two, and then relations, so like a relationship. So this is going to be like how two variables influence each other or relate to each other. This does not mean that one variable is going to cause the other. We can only find causation when we're looking at experiments. This is just how two variables relate to each other. You can have a positive correlation, you can have a negative correlation, or you can have zero correlations. So if we're looking at a positive correlation, that means the two variables are going to either increase or decrease together. So they're moving in the same direction. That's going to be key. When we're talking about positive correlation, you need to remember that they have to move in the same direction. Positive does not mean good here. And a lot of times in psychology, positive is not going to mean good. So you just need to be aware of that. In this case, positive means they're going to be moving in the same direction, either increasing or decreasing together. So let's look at an example of a positive correlation. So say you have to go get some gas, you got to fill up your car. Usually the more gas you put in, the more it costs, right? So the number of gallons of gas pumped is positively correlated with the amount spent on gas. So the more you put in, the more money you're going to spend. And what's really cool about that is you can reverse that situation, right? The less money you spend on gas, the less amount of gas is actually pumped into your car. So remember, when you're looking at these, are they moving in the same direction or not? So negative correlation is just two variables that move in opposite directions. So for example, say you've got a full tank of gas and you're driving. Well, the more miles you drive, the less gas you're going to have, right? So they're moving in different directions. So positive, same direction, negative, different directions. A scatter plot. So most of you have heard of a scatter plot before, you've seen one, but we're going to use these in psychology to show correlation. So this is a graph comprised of points generated by values of two variables, right? The slope of the points is going to depict the direction, and the amount of scatter is going to tell us the strength of the relationship. So let's look at some pictures to make it a little bit more visual. So right here with our first scatter plot, you can tell that all of the dots are in line with each other, and they're both variables, the x and the y, are moving in the same direction. This would be a positive correlation. Now, this would be a perfect positive correlation. You don't really ever see that, but in real life, but you can see that the dots are moving in the same direction, and they're in a perfectly straight line. So that lets you know that it's positive. Here is a picture of a negative correlation. Again, this would be perfect. You're never going to see a perfect correlation, but this is what your graph is most likely going to look like if you have a negative correlation, just in the fact of like that the dots are going in a line, and you can see that the variables are moving in different directions. So as the y-axis decreases, the x-axis increases. And then this last fun one would be an example of no correlation, because you see the dots are kind of all over the place and you can't tell which direction they're moving, and it's really not linear. So most of the time you're going to see correlations that are either mostly positive, mostly negative, or kind of in this no correlation zone. Okay, correlation coefficient. So I just showed you how to represent a correlation on a scatter plot, but here's how you represent it with a number. So anytime you see a little lowercase r, that's going to be your symbol for correlation. And then you're going to have a number. It's going to say r equals something, right? You're going to have either a plus sign or a negative sign right here, and that's going to determine if it's positive or negative. And then you're going to have a number. So 1, positive 1 or negative 1 is the strongest, right? So this is a positive 0.37. So that means it's slightly a positive correlation. So like I said, the plus indicates the direction, and then the number indicates the strength. So the closer that number is to 1, the stronger it is. The closer that number is to 0, the weaker it is. And it's always going to fall within -1 to +1. You can't have a correlation of 1.5 or 2.5. It always has to fit in between -1 and +1. Okay, let's take some of that information that we just learned and see if we can apply it to some examples. So you have a plus sign and then you have 0.78. So if you're looking at that, hopefully you would recognize that the plus sign means this is positive, and then 0.78 is a pretty strong correlation. So this would be a positive correlation, and it would be moderately strong. Because remember, just the plus or negative determines if it's positive or negative, and then just the number determines if the strength. So come up with an example of two variables that would have this type of positive correlation. Okay, next one has a positive sign, a plus sign, but then it also is 0.05. So hopefully you recognize that that is very, very weak, because 0.05 is very close to 0, and we know 0 is where we find no correlation, but it still is positive. So it's a very weak positive correlation. So what would be an example using two variables that have this correlation? Now, if you're like, what? How am I supposed to figure that out? Just kind of think it through. So what are two things that could maybe move in the same direction but really don't relate to each other? So in this case, you could maybe say happiness increases with the more purple socks that you own. So they would technically be going in the same direction, but there's probably not a real relationship with happiness and purple socks. As opposed to this one could be as your height increases, your weight increases, right? Because that's not always the case, but most of the time, the taller you get, the more you weigh. Or it could go the other way. The shorter you get, the less you weigh. So just think in your mind of some examples that you could create to fit these correlations. So now you see one that has a negative sign in front, so you know that it's going to be a negative correlation, and it's 0.43. And remember, the number determines the strength. So this is pretty weak because it hasn't even hit 0.5. So it's definitely closer to 0 than it is to 1. So this is a moderately weak negative correlation. So do the same thing. Come up with two variables that could be an example for this correlation. Okay, last one. You have a negative sign, so you know that it's a negative correlation, and you have 0.92. Well, that's really close to 1 or -1, right? So that you know that this is a very strong negative correlation, because this number right here is very close to 1. Okay, same thing. Come up with an example of something that is really, really two variables that are very, very correlated with each other, but they're moving in opposite directions. Okay, so here's a scatter plot example. So instead of looking at the correlation coefficient, we're going to move back to the scatter plot. So we're going to be looking at two things. We're going to be looking at temperament scores, which is pretty much just your temperament is like your emotional reaction to life, basically. So are you more like high strung or are you more chill? And then we have your height in inches. So those are our two variables. So if you're looking at this scatter plot, you probably can see that there is a increase in slope, right? As your temperament scores increase, your height increases. So you can see that it's kind of moving in that positive direction, except there are a lot of dots that are not around that line of best fit. So you probably can tell that it's not a super strong positive correlation. So this would be moderately positive, maybe a 0.63, because you can tell that there's a correlation there and that it's positive, but you still have a lot of dots in other places. Okay, so let's look at correlation and causation. Now, you cannot say that two variables by themselves cause each other if we're looking at their relationship. So let's look at an example. If you have two variables, let's take low self-esteem and depression. Well, someone might come to you and say, well, low self-esteem causes depression. Maybe, but then you could flip that around and you could say depression causes low self-esteem. Maybe. Or there could be a completely other variable that needs to be factored in, like distressing events or a biological predisposition causes low self-esteem and depression, right? So if you just have two variables and you just see that they're correlated, you cannot, I repeat, you cannot, one more time, you cannot say that correlation causes causation, right? No, you cannot, right? The only way we are going to see if something causes something else is if there has been an experiment. That is the only way we can say causation. So if you just have two variables that are correlated, you cannot, one more time, you cannot say that one causes the other. We've got three different types of research. We've got descriptive research, which is a fancy way of saying observational. So basically, we are just observing and describing a behavior, or we're just watching, right? Just observing and describing. Then you have a correlation, which is what we just talked about, right? We can find the relationship between two different variables. And another one is experiments. So this is where we have a controlled setting and we manipulate different variables. And remember, experiments are the only thing that can tell us causation. Okay, so let's look at one type of research method. We have naturalistic observation. So this is just observation of a human or animal behavior in the environment in which it typically occurs. So we are just watching and then writing down or describing the behavior. We're not interfering, we're not controlling the situation, just simply watching. So Jane Goodall, if you know a little bit about her, she's a perfect example of naturalistic observation when she went and lived and watched gorillas for a long period of time and gained a lot of information from that. So it's a really good research method. However, sometimes there can be some issues, and you're going to see issues with all of these research methods. So it's valuable because it usually isn't disruptive or misleading. However, sometimes people, if they know they're being observed, they're going to act differently. So think about whenever you have a teacher and they have to get observed by an assistant principal one day. Do they tend to act differently? Do the kids tend to act differently because they know someone's watching? Usually, right? And so that can be a downfall of this, because with our ethics that we studied last video, you have to tell someone if you're observing them. You can't just follow someone around and write down all their behaviors without letting them know. So ethically, you have to tell someone you're observing them, which we just talked about sometimes makes them act differently. So to combat that, you have to observe them over a long period of time. So in hopes that maybe like they'll return to normal behavior. Also, observations can be distorted if the person observing expects to see certain behaviors. So if I'm observing someone and I want to see their temperament and I expect them to get angry all the time, the first time they get angry, I'm going to be like, oh, yep, see, they're an angry person, and write it down. So sometimes the own expectations of the observer can create some bias. The next type of research method that we're going to look at is a case study. So this is the intensive examination of a behavior and mental processes associated with a specific person or situation. So let's start off with the example here that'll help explain the definition a little bit more. So we had an individual, we called him patient HM to protect his identity, but he had to have extensive brain surgery, and he had to have part of his temporal lobe removed as well as his hippocampus. And those are very, very important parts of the brain. And so, because this surgery was done out of medical necessity, psychologists wanted to study him to see, okay, if these parts of the brain are removed, then what happens? And you can do that if there's a medical necessity. But for example, we can't just take some guy off the street and say, hey, let's cut out parts of your brain and see what happens, right? That's very unethical. We cannot do that. And so that's where case studies become really, really important, in the fact that we can examine certain situations or bizarre things that happen, and then later that information can be used to further research and to further explore different things. So if you want, you can always look up HM. But just like anything else, a case study is going to have its benefits, but then it's also going to have some limitations as well. So a benefit is it's really useful when something is new, complex, or rare, right? A lot of people aren't having parts of their brain removed, and so when they are, we can really study that. And so a lot of times it's used in clinical work, so with disorders, and then neuropsychology, so specifically looking at the brain. However, there are limitations, right? It could contain evidence that a certain research thought to be important. So it kind of narrows the focus a little bit, if that makes sense. It's really hard sometimes or psychologists will want to take this one example of something that happened to one individual and relate it to a group of people. And that can be a problem, because sometimes the case study is not representative of people in general. And there are different thoughts that might be more important. However, it's super, super valuable in allowing us to further our research in testing new treatments, new trainings, and anything else. So case studies are very important. Just remember, with case studies, you can't generalize. You can't say that because this happened to one person, it's going to happen to everyone. So make sure you put that in your notes somewhere. Okay, a survey is a technique for gaining attitudes, opinions, or behaviors of people, and we're trying to find a representation of a larger population, and we're going to use random sampling to do that. So make sure you understand that random sampling is going to be for surveys, because we're going to look at random assignment when it comes to experiments, and those are two different things. So surveys can be used as a part of the operational definition within experiments, but a lot of times we're going to see these separate, and we're going to use them to gain a lot of information from a large group of people. So if we are looking at a survey, we need to focus on a couple things. How are the questions worded? Because how the questions are worded can then prime certain answers from the people filling it out. So for example, take a controversial issue like abortion. Okay, and if you're giving a survey to someone and you phrase the question as, how do you feel about women being able to choose what happens to their body versus how do you feel about the unborn child being murdered? Those two questions are going to give you two very different answers, even though they can both fall under the same topic of abortion. So we really want to make sure that if we're creating a survey to gain information, we want to avoid biases and we want to create those questions as objective as possible. And then we want to make sure that we have a representation of the people surveyed. So if you are trying to survey everyone in the state of Texas, but your random sample or your population that you're looking at is only 25-year-olds in Dallas, well, I guarantee you 25-year-olds in Dallas, those people, even though we're great, are not representative of the entire state of Texas. So you want to make sure that your random sample or your sample is going to give you the information of the population that you're trying to look at. We've got some other limitations. So some people will take a survey and they might not answer it completely honestly. They might put down what they believe they should say on an issue or what they think is politically correct. Also, think about people filling out reviews on restaurants or stuff like that. Who normally fills out surveys and reviews? You either have someone who's passionately for that place, like maybe you're the biggest fan of Red Lobster, right? So you're going to go on Yelp and you're going to type out all of the great things about Red Lobster, right? Now, who's the other type of person that's going to fill out like a review or a survey? Well, it's probably someone who's very passionate in the dislike category. So if you went to Red Lobster and there was like hair in your food and your food was cold and the server was mean to you, you're going to passionately fill out a review about how crappy Red Lobster is, right? So we want to take that into consideration as well. Sometimes when people fill out surveys, we get those extreme feelings of either passionate agreement or passionate disagreement. So we want to keep that in mind when we're looking at surveys. However, like I said before, still a great way to gather large amounts of information. Okay, lastly, we're going to look at quasi-experiments. So these are studies that have the same control as experiments, yet do not include the random assignment of participants. So with this, when you take notes over experiments and all of the fun stuff that goes into that, this is going to make a little bit more sense. But as of right now, I want you to kind of view quasi-experiments as almost fake experiments because you're gaining information, but you're not setting up an experimental group, a control group, and bringing people in. Now, the purpose of this is because there are times when we need to gather information, but we're not able to do an experiment because it wouldn't be ethical. So let's look at our example. Researchers want to test the hypothesis that a pregnant woman's use of drugs will cause abnormalities in her developing baby. Now, let's think this through. We're trying to figure out the effect of drugs on babies in the womb. So, can you gather women and say, okay, all of you are going to get pregnant? Well, no, you can't tell women that they're going to get pregnant. And then split them into groups and say, okay, My experiment group, you are going to, um, do crack for 3 times a day and we're going to see what happens to your baby. No, you can't. You can't do that. That's not ethical. You can't make people get pregnant and you can't make pregnant people take drugs. However, are there women who do drugs while pregnant? Yes. It's very sad. It's not okay. But there are women out there. So if you can find them and observe, okay, you took these drugs and this is how it affected your baby, then we can gather information that way, if that makes sense. Okay, so conclusions from these quasi-experiments, they're not as firm as those drawn from true experiments that were set up in a controlled setting manipulating variables. However, they allow for research to be conducted on topics in settings that would be otherwise impossible. So it is a way to gain information in areas where we can't set up an ethical experiment. So that's the end of this video. Make sure that you have filled out your notes on research methods, and in our next few videos we're going to jump into experiments and all of the fun stuff that goes with that. Means I'm over this already.